Okay, so continuing on about these rates of reactions, we're going to get to specifically about first order, zero order, second order, and zero order reactions. So right now, first of all, what does it mean to be first order? That means it's the first power. Or so if you had some reaction, A makes products. Right now, let's just assume one reactant. Okay, A makes products. To say something is the first order, that means it's to the first power. Okay. Well, we also know the rate of the equation is equal to minus change in A over change in time. And to say that's first order, by the way, I'm assuming first order. We'll talk about what if it's second order, zero order in a second. And rates of equation, the rate orders are usually 0, 1, or 2. Most of the time, like 99% of the time, fine, 95% of the time is 0, 1, or 2. Sometimes it also could be a half, but for high school, we're not going to deal with that right now. Okay. But let's do like 95% of the reactions. Actually, it's probably more like 99% of reactions. So the rate is equal to K times A to the first power. Again, let's assume first order. Okay, so that means mathematically if rate is equal to K times A, then K is equal to rate divided by A. Okay, the units of this, rates is measured in molars per second. A is measured in molarity. Molars and molars cancel. So you have per second or S to the minus 1, same thing. So that's just about the units. That's what this is all about. So the units of K for first order reactions are 1 over S, or 1 just per second. In other words, S is for seconds, per second. Okay, so if this is rate, that is rate, they're equal. Now, the next thing I'm going to get from here is a little bit of calculus magic. I know none of you are in calculus, at least I assume you're not in calculus. But to go from this equation to the next equation, which I'm just going to put up right here, involves a bit of calculus. Where did this equation come from? I'm just telling you, it's a bit of calculus that unless you're in calculus right now, you don't know how to do it yet, but you will one day, okay, when you take calculus. So I'm just going to say, okay, math magic, we get this, okay? What does the equation say? This says natural log of A is equal to natural log of A naught minus KT, where A is the concentration A at any time. A naught is the initial concentration, is the concentration A when T equals 0, meaning the initial. When T equals 0, meaning you just got started, when time just starts. So how much you have, the log of it, is equal to how much did you start off of it, did you start off with, the natural log of that, minus a constant times time. So I know you don't know where this equation came from. I'm just telling you that's what it is. ln here is the natural log. And you should have learned natural log in Algebra 2. And yes, there's going to be some fun log rules that are going to be coming up soon. But they are, that's what they are. Okay, so going on. So I'm going to skip this one for now. Let's say we have here reaction 2A makes B. It's the first order with respect to A with a reaction constant of 2.8 times 10 to the minus 2 per second at 80 degrees Celsius. How long will it take for A to go from 0.88 molars to 0.14 molars? Okay, let's put up the equation first. The equation is this. Natural log of A is equal to natural log of A naught minus KT. So I know it seems confusing, but this is actually not really that hard. It's kind of like, besides that there's logs in this, this is kind of like the chapter on gas laws. So you have an equation. You just, for now, just plug into equations. So what do we know? We know the constant. That's K. The rate constant, K, is 2.8 times 10 to the minus 2. That's K. What else do we know? This question is how long? Meaning I'm solving for T. So somehow I need to solve for T. K, 2.8 times 10 to the minus 2 times T. Okay, I'm solving for T. Then I also need to know what A and A naught is. A is how much you have. A naught is how much you started off with. And it tells us, it told us. It decreased from 0.88. So the initial amount was 0.88. And at the end, it was 0.14. So I know A naught. I know A. I also know K. So there's only 4 variables. I know A naught, I know K, solve for T. So, okay, this is just mathematically. subtract natural log of A naught from both sides, but also bring the negative sign over. So K times T is equal to natural log of A naught minus natural log of A. I'm solving for T, so divide both sides by K. Okay, next one. This is just a math rule. Log of X minus log Y is equal to log X over Y. Okay, if you don't remember that, don't worry about that right now, but it's just one of your log rules. Log X minus log Y, as long as they're same base, will equal to log X over Y. Okay, you don't have to do it this way, but I did. Now, I know A naught, I know A, I know K. K is right there, it's given. Plug everything in. This is A naught, that's A, that's K. Notice molars cancel. And this is now plug in a calculator. I get 66 seconds. So how long will this reaction take? It'll take 66 seconds for this reaction. Okay, so that's not that bad. Now, let's get to another term called half-life of first-order reactions. Half-life is the time it takes for a concentration of reactants to decrease to half. So the time, symbol for half-life is T1/2, is the time it takes for A to have half of the original. If the original is A naught, half of that is when T is a T when A is equal to half of A naught. Okay, now let's go back to that last equation. Remember the time, go back here. Time is equal to natural log of A naught over A over all over K. Well, if half-life will be natural log A over A naught over A, but A at half-life is A naught over 2, all over K. Notice A naught and A naught cancels out, or in other words, you have natural log of 2 over K, which is about 0.693. So for first order reactions, the half-life of a reaction is equal to natural log of 2, or 0.693, divided by K. I can use that to solve this problem. What's the half-life of N2O5 if it decomposes at a rate constant of 5.7 times 10 to minus 4? Okay, so I'm given K. I'm trying to find a half-life. Half-life is natural log of 2 over K. I'm given K. This is just plug in a calculator. Half-life is 20 minutes. Okay, or well, 1200 seconds if you want to change the minutes, 60 seconds in a minute. About 20 minutes. Okay. How do I even know this thing is a first order reaction? Based on the units. First order reaction, the rate constants, the units are per second. So that's how I knew that. Okay, going on. So what is half-life again? Half-life is when you have half of the original product. But in 2 half-lives, it doesn't mean it's all gone. You'll have half of the half left, or 1/4 of what you have. In 3 half-lives, you'll have half of a half of a half, or 1/8. In 4 half-lives, you'll have half of a half of a half of a half, or 1/16. Theoretically, it'll never be all gone. You'll always be halfway, or you always have half left, you can say. But so in 1 half-life, you have half. 2 half-lives, you have a half of a half, or 1/4. 3 half-lives, half of a half of half. 4 half-lives, half of a half of a half of a half. It's not on here, but 5 half-lives will be 2 times 16, or 32. Okay, or 1/32, or divide by 32 of the original amount. Okay, so 1 half-life, half. 2 half-lives, half of half. 3 half-lives, half of half. 4 half-lives, half of half of half of half. Okay, so that's what this means for half-life. Okay, we just did first order reactions. There's also zero order reactions. Or sorry, this is second order reactions. Second order means to the second power. Okay, rate still the same minus change in A over change in time, but the rate is equal to K times A to the second power, or second order. Now, if I'm solving for K is equal to rate divided by A squared. It's technically called second order. I'm going to say squared, but because it technically is. But it's called second order when we call it. Okay. Rate is measured in molars per second. A is measured in molars. So notice the units for a second order reaction will be 1 over molar seconds. So that's how I can recognize an equation second order just by the units that are given. Okay, now this is the rate, that's the rate. They're equal. Now the next thing I kind of mentioned before is a bit of calculus. None of you are in calculus. Pause for a second. Okay, so these two are equal, and a bit of calculus magic that you don't know, I can turn that equation into this. Okay, I'm not going to go there how you can learn that when you take calculus. Okay, for those that are in calculus, integrate both sides. Okay, where A is the concentration of A at any time t, A naught is the concentration of A at the original amount, the initial amount. So it's the same thing as the first order reaction, but there's a different equation. 1 over A is equal to 1 over A naught plus KT. And again, reminder, half-life is when you have half the original amount. So if I want to plug in for half-life, half-life is plugging in if A is equal to half A naught, solve for T, is already done algebraically. Half-life is 1 over K times A naught. Okay, so that's the equation for second order reactions. What if it's a zero order reaction? Zero order means to the 0 power, or anything to 0 power is 1. Rate is equal to K. So, well, rate is equal to K is equal to rate divided by A naught, which is 1, or in other words, just 1. So the K, the rate units for K are just molars per second. So in a zero order reaction, the units are molars per second. Okay. This is rate is K. They're equal. A little bit of calculus magic and we get this equation. A is equal to A naught minus K times T, where A is equal to concentration A at any time T. A naught is the concentration of A when the initial concentration, when T equals 0. Again, half-life is when A is equal to half of A naught. So if I plug in A is equal to half A naught, then I solve for T. Algebraically, half-life is equal to A naught over 2K. Forget the next sample equation. No, not yet. Okay, I know that's a lot of equations, so here's a summary of all the equations so far. If this was in class and we had a test on this, I would give you these equations. You would not have to memorize all these equations because that's a lot of equations and there's logs in them. So this is just a summary. Zero order reaction, the concentration time equation, A is equal to A naught minus KT. If it's first order, it's natural log A minus natural log A naught minus KT. Second order, 1 over A is equal to 1 over A naught plus KT. And here's the half-lives. So I think that's, nope, that's not it. Pause for a second. Actually, that is it for today's lecture. And so that's just a summary of zero, first order, and second order reactions. And we'll continue on with the stuff next time.